In this video, we'll go through a matched pairs T procedure. Let's go ahead and read this problem. Blastobike, a bicycle manufacturer, claims their bike will increase speed and hence reduce route times for cyclists. To test their claim, a simple random sample of 5 competitive cyclists were asked to record their times on the same route, while first riding a standard racing bicycle and then riding a Blastobike. The population of cyclists is normally distributed, and the times are recorded below. Well, we know this is going to be a matched pairs procedure because we have 2 dependent measurements. The standard route time and the Blastobike route times are paired among the cyclists. There's 2 quantitative measurements taken on 1 unit. So this means we have to do a paired procedure. Cyclists want to know, does on average the Blastobike reduce cyclist route times? So we need to perform a matched pairs t-test. We're going to use a significance level of 0.05. The first step is to state our null and alternative hypotheses. So here we have h naught, which is equal to mu d. This is our parameter. And what is this guy? This is the average difference So that's what mu d is. So basically, once we take the differences, what is the average difference in the population between the 2 dependent populations? Well, mu d we're going to claim is equal to 0. This is always going to be the null hypothesis in this case. And the alternative hypothesis, mu d, is either going to be, it's going to be one-sided. And the reason why is because it asks whether or not the Blastobike actually reduce cyclist route times. So depending on which way we subtract, that's the direction in which we're going to put our inequality. Well, I always like to subtract based on how we did it in elementary school, which is essentially take the bottom value and subtract it from the top value. So like for our first observation here, the difference is 0.8. So simply subtract 29.1 or 28.3 from 29.1, and we get 0.8. What this means is if we were to get all positive values, so if our average is greater than 0, what that means is that then the Blastobike would actually decrease route times because it was faster. So our alternative here will be mu d is greater than 0. So the next step is to check our conditions. Do we have a random sample? Random sample, yes we do. We have a random sample of 5 cyclists. And we know that the differences are normally distributed. So this is met to our second condition. We have a pretty small sample size, but if we know that the differences are normally distributed, then we should be okay to perform a t procedure. So the next step is to perform or to calculate our t-test statistic. We're going to do this using the TI84. So let's go to our TI84, and the first step is to put in the list of data. So we have 2 lists. We have L1, which is the standard bicycle route times for the 5 cyclists. So 29.1 is cyclist 1, 33.2 is cyclist 2, and so on. Then in L2, we'll put in the Blastobike route times. From here, we will take the difference between the 2 lists. We could do this by hand, or we can do it using our calculator a little bit quicker. So to do this by using the calculator, we want to scroll up to L3. Then once we have this part highlighted, the L3, we can put in what the command we want to create using L3. So we put in second L1 minus second L2, because this is taking the subtraction or the difference between these 2 lists. And we get the differences between the standard bicycle route times and the Blastobike route times. Notice that 0.8 is the same as we got by hand over here. So if we did it all by hand, or if we did it using our calculator, we'd get the same values. It's up to you what you would like to do. The main thing is that we should put in the list of differences. This is what we'll use in our t-test command. So the next step is go to stat, scroll over to tests, And we're going to use a one-sample t-test on the differences. Press Enter. Then we want to choose Data because we have a list of data, or differences. Our claim is that the average of the differences is 0. We have the list as L3, so this doesn't need to be changed. However, if we needed to change it, we could put second and L3. Scroll down. We want to make sure that we match our alternative hypothesis. So we're doing mu d is greater than our claim of 0. So that alternative is correct. And press Enter. Here we get a t-test statistic of 3.83 and a p-value of 0.009. Notice how our x-bar and our sample standard deviation are also listed. So we could technically do this by hand as well, using these values. All right, so once again, our t-test statistic is 3.8 and our p-value is 0.009. So t is equal to 3.8 and our p-value was equal to 0.009. Well, what does this mean in the context of the problem? It means that there is convincing evidence that the Blastobike reduced route times. And we're going to be able to reject the null from a significance level of 0.05. And in parentheses, I'm just going to include my my t-test statistic. It's important. Our t-test statistic of 3.8 and p-value of 0.009. You should also perhaps include here the degrees of freedom, which in this case, because we have 5 pairs, our degrees of freedom would be equal to 4. In addition to including the statement in terms of the alternative and whether or not we should reject the null based upon a significance level, we could also include a confidence interval. In this example, I'll leave it as this, and I'll let you answer the confidence interval part.